Hello,
Whatever.
can you hear me? Your voice is not very clear. You have to speak in the mic.
Um, Good evening, sir. It is
Yeah, great. Uh, okay, so exercise 20, you have three doubts.
yes, yes,
Question 28. Question 28 is quite long, but I can tell you the basic idea. Sine cube A sine of B minus C plus sine cube B sine of C minus A plus sine cube C sine of A minus B plus sine of
sir. Should I
C.
tell my process what I
What did you do?
feel like I do like sine A into sine B minus C. So I apply sine A sine B to the
1 second, just hold on. There is someone at the door. Okay, so we have to prove that this is equal to 0. Now you have to figure out how to simplify these expressions.
yes,
So the way to simplify this is to try to remove the sine cube A somehow. And the only way to remove sine cube A is by using the sine 3A identity.
yes,
This is my identity for sine 3A. So you can say that 4 sine cube A is equal to 3 sine A minus sine 3A. So sine cube A will be equal to 3 by 4 sine A minus 1 by 4 sine 3A, right?
yes, sir.
So what you should do is each term here you should simplify like that. Now instead of sine cube A, I'll write 3 by 4 sine A times sine B minus C minus 1 by 4 sine 3A times sine B minus C, right?
Yes, sir.
So now you will get, see, you'll get three terms like this, right? From each of these, correct? Like each of these terms can be split into two terms like this, right? Do you understand what I'm saying?
Yes, sir. Like we are converting the product. uh, If
Now we are converting this product to the difference of these two, right?
yes,
We'll get two terms on each of these first three, right?
yes,
And then what we will do is we will take all the 3 by 4 terms common together and all the 1 by 4 terms together. Okay? So what will we get then? We will get something like this. 3 by 4, you will get sine A sine B minus C plus sine B sine C minus A plus sine C sine A minus B, right?
Yes.
And then you will get minus 1 by 4, and this will be the second type of terms. It will be sine 3A sine B minus C and sine 3B sine C minus A and sine 3C sine A minus B, right?
Yes.
Okay, so once you have done that, what we can do now is you have to simplify this stuff, these two brackets, right?
Yes, sir.
The way to simplify this first bracket is simply expand it. If you expand it properly, you will realize that the first bracket will vanish. Think about it. Sine A, sine B, cos C, right? So we are getting first term is what? Sine A, sine B, cos C minus sine A, cos B, sine C, right?
Yes.
Second bracket, see the terms sine B, sine C, cos A minus sine B, cos C, sine A, right? See, can you see that this term got cancelled with this one?
Yes.
Are you understanding what I'm doing?
Yes.
You also have this one will become sine C, sine A, cos B minus sine C, cos A, sine B, right?
Yes.
Now see sine C, sine B, cos A. This will cancel this and this will cancel this. Do you understand what is happening?
Yes, sir.
So this whole bracket will disappear, right?
Yes.
The whole bracket disappears and now you are left with this bracket and the last term, right? Correct. I hope you are understanding what we are doing.
Sir.
How do I simplify this bracket? What I will do is I will take minus 1 by 8 and I will put a 2 inside each of them, right? Minus 1 by 8 and 2 sine 3a sine b minus c, right?
Sine A plus B.
And do you understand what step I am saying? I have put a 2 inside and put a minus 1 by 8 outside, and this will become cos of a minus b minus cos of a plus b, right?
Yes.
This is cos of 3a minus b plus c minus cos of 3a plus b minus c. Correct? Similarly, the second one will be cos of 3b minus c plus a minus cos of 3b plus c minus a. And the third one will be cos of 3c minus a plus b minus cos of 3c plus a minus b. Correct? Do you understand? I cannot hear you. You have to speak up in the class. You cannot be quiet.
So, yes. Hello.
Yes. Do you understand what I'm saying?
Yes, sir.
After this step, now you have to think about how to simplify this part and all, right?
Yes, sir.
So what we will do is actually it will be better if we right. Actually, it will be better if we group some of the terms here. So this and this if you group first and last. Cos C minus cos T, if I do, what will happen? I will get, notice that if you do the correct grouping, first and last one, cos C minus cos T will be 2 sine C plus D by 2 sine D minus C by 2, right?
Yes, sir.
So it will be 2 sine this plus this by 2. Let's calculate what comes there. 4a plus 4c minus 2b by 2, right?
Yes, sir.
And then sine this minus this. So notice it will become 2c minus 2a, 2c minus 2a. So it will be by 2. So sine of c minus a, right? D minus c by 2. Right. So sine of c minus a will come. Uh, I wanted to get a sine a plus b plus c, but I'm not getting that right. How can I get sine of a plus b plus c? Which grouping will give me that? That's what I'm trying to think. This minus this will give me what? 3a, 2a plus 2b. Oh yeah. Yeah, I've done the wrong grouping. I want to group this one with this one. Okay. Why am I saying that? If you group that, you will get 2 sine a plus b plus c, I think. Do you see what will happen? This minus this, okay? First term will be c plus d by 2, right?
Yes,
What is 3a minus b plus c plus 3b plus c minus a by 2? Notice it is 2a and plus 2b and plus 2c by 2, right?
yes,
And the other term is sine d minus c by 2. This minus this by 2. So 3b minus 4b, c minus c gets cancelled, and minus a minus 4b minus 4a by 2. So 2b minus 2a, right? So see that you are getting 2 sine a plus b plus c, right?
yes,
The point is that I grouped the first one and the fourth one. Similarly, I can group maybe this one and this one. When you add it, see what happens. 4a, okay, 4a I don't want, so that is not correct. So I'll group this one and this one. I'll get 2b plus 2c, okay. Second one and sixth one, right?
yes,
Do you see how you'll group and you'll get 2 sine a plus b plus c common every time?
yes,
Once you get sine a plus b plus c, now you can take everything common. No, sine a plus b plus c from the 3 terms here and from the last term also, right?
yes,
It is long and difficult, but it will come eventually. Okay? I don't want to spend too much time on it. It's fine. But you get the idea what you're doing, right?
yes, sir.
Okay. Question 29 is sine A, sine B, sine of A minus B. Okay, similar terms, sine B, sine C, sine of B minus C, sine of B minus C, and sine C, sine A, sine of C minus A, sine C, sine of C minus A, plus sine of A minus B, sine of B minus C, sine of C minus A is equal to 0. Okay, so fine. So,
Here we have,
tell me, what have you done here?
I just try to group like paper formula, like sine A, cos
Your
A.
voice is not audible.
Is it audible now?
Yes.
Sir, like I try to make a group
Like I try to prove like sine A into sine A minus B, and I convert it like the formula sine A minus B minus sorry cos A minus B minus cos A plus B. Like
You have to convert sine A sine B into cos minus cos.
yes,
You can
cos
write it
A minus
as this, and this will become half of cos of A minus B minus cos of A plus B into sine of A minus B, which will become half of cos A minus B sine A minus B minus cos A plus B sine A minus B. And then obviously we can use formulas again. I need another half outside so that I can put 2 both ways, right?
yes sir.
If I put 2 here, this is clearly sine of twice of A minus B. And here I am getting a 2 cos A plus B sine A minus B, right? So you can write it as this is 2 sine A minus B cos A plus B can be written as, you can think of this as C and think of this as D. So that is clearly sine of C plus D plus sine of C minus sine of C plus D minus sine of C minus D, right? Plus sine of C minus D. That will be 2
Yes sir.
cos C cos D. So when you write that, it is sine of C plus D is 2A plus sine of C minus D is minus 2B. So this is same as sine 2A minus sine 2B, right?
Yes sir.
So we get here minus sine 2A plus sine 2B. This is what we get here. So we can write 1 by 4 outside and so on. And you will get similar terms in all the first 3. The first 3 will simplify in a similar way, right?
Okay sir.
So what are we getting? Notice that minus sine 2A plus sine 2B is coming here. It will be minus sine 2B plus sine 2C here and minus sine 2C plus sine 2A here. So all of that will cancel, right?
Yes sir.
These two terms get cancelled when you add for all 3. So what you will be left with is 1 by 4 of this plus 1 by 4 of sine 2A 2B minus sine 2C 2B minus 2C and 1 by 4 of sine 2C minus 2A, right? Correct.
Yes sir.
Great. So now what we can say is try to simplify that now. Right. So I can write this as now finally 1 by 4 sine 2 times A minus B plus 1 by 4 sine 2 times B minus C plus 1 by 4 sine 2 times C minus A. This is my first 3 terms. I will not worry about the last term right now. I will just try to simplify this. So I'll take 1 by 4 common and write, group the first 2 terms together. Uh, right. So, but no, not group the first 2 terms together. What you can do is, we can say this is 2 sine A minus B. Okay, maybe we should just group the first 2 terms together. Let's just group the first 2 terms together and see what comes. This plus this, right? Sine C plus sine D. It will be 2
Yes.
sine 2a minus 2b plus 2b minus 2c by 2 and cos 2a minus 2b minus 2b plus 2c by 2, right? Correct.
Yes, sir.
So this is becoming a minus c 2 sine a minus c, and this is becoming cos of a minus 2b plus c plus, notice you can take common here, this will become 2 sine c minus a cos c minus a, right?
Oh, yes, sir.
I can
2
take 2
sine.
sine a minus c common outside, right?
Yes, sir.
2 sine a minus c common. I will get cos of a plus c minus 2b minus cos of c minus a, right?
Yes, sir.
And I will write this as cos c minus cos t, so that is 2 sine this plus this by 2, so that will be a will get cancelled, c will become 2c minus
B
2b,
minus
so
C.
and
Oh, yeah.
sine d minus c, this minus this, c minus a minus a minus c, so c gets cancelled, minus 2a plus 2b, so it is b minus a, right?
Yes, sir.
Notice that you're getting a 4, this is getting cancelled, you are getting product of these three, and this is clearly, you can convert this to negative sine c minus a, convert this to negative sine a minus b, and convert this to negative sine b minus c, and this is negative of the third term, right?
Yes, sir.
This product is negative of the last term, no? So when you add it, it becomes 0.
Yes, sir. Understood.
The first idea is correct, but after that you have to continue doing things. You can't stop. You have to notice that the second and third terms get cancelled, right?
Yes, sir.
Okay. 35. 35 is saying if x plus y plus z is equal to xyz, if x plus y plus z is equal to xyz, prove x into 1 minus y square, 1 minus z square, plus y into 1 minus z square, 1 minus x square, plus z into 1 minus x square, 1 minus y square is equal to 4xyz. Okay. Now notice one thing. This kind of result has been seen before by us in triangles. You have proved already, or we have proved already in triangle ABC, tan A
Yes, sir.
plus tan B plus tan C is equal to the product, right?
Yes, sir.
So this result is valid in a triangle ABC where A plus B plus C is equal to 5, right?
Yes,
So
sir.
if they have given us a condition like this, tan function can take any values. There is no restriction on tan function. If you see the graph of tan function, it is like this, going from minus infinity to plus infinity, right?
Yes, sir.
This is my tan x. Now think about it, since tan x can go from minus infinity to plus infinity, there is no restriction. Any x can be thought of as tan of some angle.
Oh,
No,
yeah.
no
Understood,
matter
sir.
what, no matter what x is there, x is 15. 15 will also be tan of something.
Yes, sir.
That is not the case if I had sine x, sine A, sine B, sine C. I cannot take any x as sine A, right?
Yes, sir.
Because sine A and cos A have a restriction between minus 1 to 1, right?
Yes, sir.
So output of sine A and cos A cannot be anything. However, output of tan function can be anything, right? Any real number.
Yes, sir.
Also, right now what we are getting is, if I take x as tan A and y as tan B and z as tan C, I'm getting a relation tan A plus tan B plus tan C is tan A, tan B, tan C, right?
Yes, sir.
Which tells us that the angles A plus B plus C must be pi then. Why?
Yes, sir.
Because if this result is true, then angles must have been part of a triangle, right?
Yes, sir.
So what we are going to do in this question is just substitute. There is no restriction required on XYZ. So we can say XYZ is tan A, tan B, tan C, where A, B, C are unknown. But because of this condition, we have realized that A plus B plus C is pi, right?
Yes, sir.
Okay. So my X is tan A, Y is tan B, Z is tan C. And I also have learned that A plus B plus C is equal to pi, right?
Yes, sir.
Now, what you can also do from here is 2A plus 2B plus 2C is 2 pi, and try to take tan of 2A plus 2B plus 2C. You will realize that tan of 360 is 0 because sine of 2 pi is 0, right?
Yes, sir.
And when you do tan of some three angles, the formula of expansion is always S1 minus S3 by 1 minus S2, right?
Yes, sir.
So if tan of 2A plus 2B plus 2C is 0, that means S1 is equal to S3 then.
Yes, sir.
Basically, we get the result that tan 2A, S1 will be tan 2A plus tan 2B plus tan 2C, right? Must be equal to S3, which is tan 2A into tan 2B into tan 2C, right?
Yes, sir.
Do you understand how this is coming?
Yes, sir.
So this is the result that will help us prove the question, because now we have proved that tan 2A plus tan 2B plus tan 2C is equal to tan 2A times tan 2B times tan 2C. And now we can say double angle formula tan 2A is 2 tan A by 1 minus tan square A plus 2 tan B by 1 minus tan square B, right? Plus 2 tan C by 1 minus tan square C, right?
Yes, sir.
That is equal to, just do the expansion of this also, write it like that only, right?
Yes, sir.
So
Like,
it will be what? 8 tan A tan B tan C divided by the product of all of these, right? 1 minus tan square A, 1 minus tan square B, and so on.
yes, sir.
So notice that now we can multiply both sides with this denominator, right? Correct? And you
Yes,
will
sir.
get, you can also cancel 2, you will get 4, right? You will get tan A into 1 minus, notice what will come here, 1 minus tan square B, 1 minus tan square C, right?
Oh, yes, sir. Got it.
Now it is done. Basically, you are
Yes, sir.
getting the thing. Now put back
Yes,
x, y, z, you will get this solution, right?
yes, sir.
So the idea is like these identities are important because they help you practice how to manipulate trigonometric functions and expressions. It's not like you have to remember too many things. Some things you should remember, like tan A plus tan B plus tan C is tan A, tan B, tan C in a triangle. Things like that, right?
Yes, sir.
Exercise 21 is going to be an application of trigonometric equations that we learned in the previous classes, right?
Yes,
So
sir.
what you need to do, you need to try exercise 21. I will show you one or two questions, but you have to try it yourself. It's not very difficult now that you know how to simplify trigonometric stuff. So, for example, I will show you one or two of them. So, let's look at question number 7. They are asking us to solve the trigonometric equation cos theta plus cos 2 theta plus cos 3 theta equals 0, right?
Yes, sir.
Ideally, I want to use the formula cos theta is equal to cos of some angle which is known. And then I can say theta will be 2n pi plus minus c, right?
Yes, sir.
So I have to simplify this to get to this stage, right?
Yes,
So
sir.
what I will do is I'll group first and third one together. That will give me 2 cos c plus d by 2, which is 2 theta, and cos c minus d by 2, which is theta minus 3 theta by 2, which is theta only, right?
Yes, sir. Now we can take cos 2 theta common.
Yeah. So now you take cos 2 theta common and you get 2 cos theta plus 1, right?
Yes, sir.
And now we have two options. You have one case which is cos 2 theta is 0, and the other case is cos theta is equal to minus half, right?
Yes, sir.
Cos 2 theta is 0. Basically, this 0 can be written as cos pi by 2. You have cos 2 theta is equal to cos pi by 2. So 2 theta is equal to 2n pi plus minus pi by 2, right?
Yes, sir.
Theta is equal to n pi plus minus pi by 4, right?
Yes, sir.
And from here, you can say minus half is cos 120. So 2 pi by 3. And from here, we're getting theta is equal to m pi plus minus 2 pi by 3, right?
Yes, sir.
N and m are any integers, right?
Yes, sir.
So the combined answer is basically this or this, where n and m are any integers, right?
Yes, sir.
Do you understand?
Yes, sir. Understood.
Basically, this whole exercise is practice. If you know how to solve, if you know how to simplify trigonometric expressions using the old rules of how to do general solution of equations, you should be able to solve the questions in exercise 21. Okay.
Okay, sir.
Ultimately, you have to get it to a situation where maybe you have a product of some factors which is zero, or maybe you have one or more than one conditions where sine theta is something or cos theta is something which is known, right?
Yes, sir.
If you are able to simplify it like that, then your job will be done. Okay. So
Okay, sir. We'll try.
you have to try it because such questions appear many times. Like solving trigonometric equations, these type of questions appear in JEE mains also and advanced also. So try as much as you can, see which ones you are getting, what you're not getting. Okay.
Okay,
We,
sir.
we will discuss the doubts later. Like whatever doubts are there, we'll discuss in the next few classes. So right now, what I want to start theory wise is chapter 12. Chapter 12 is the most important chapter in this book. Chapter 12 and then chapter 15. There are two chapters that we have to do that are left. So chapter 12 is basic properties of triangle. So the first thing that we will see here is, let me just check once, what other is there? Chapter 12.
Yeah, so like they have given sine rule, cosine rule.
Yeah, so sine rule, cosine rule, sides and angles. Right. Chapter 15 is advanced level of chapter 12 only. Chapter 12 is the basic level. So fine. So we'll start with a triangle and some standard notation. So if you have a triangle like this ABC, so first of all, you have to realize that anytime we work with triangles, we label the angles with capital symbols, right?
Yes, sir.
This angle is capital A, capital B, capital C. Always the label of the angles is with capital letters. Okay? And what we will say is the side opposite to the angle will be called this side. The length here will be called small a.
Small a. Yes, sir.
This one will be small b and this one will be small c. Right?
Yes, sir.
The first thing in the chapter that we learned is how to find area of a triangle. Area of a triangle ABC in general. Right? So
Yes, sir.
you already know that area of a triangle is half BC, half base into height, right?
Yes, so now we have Heron's formula too.
First, we will do half base into height. So area of the triangle can be written as half into h into a, right?
Yes, sir.
Okay. So now h can be written as, because you have dropped a perpendicular, think about it. There is a triangle here, right?
Yes, sir.
There is a small triangle here, A, B, and D, if you call it, right? So
Yes.
in that triangle, you can say sine of B is equal to h by c, right?
Yes, sir.
So h is equal to c sine B, right?
Yes, sir.
We can write it as half into c sine B times A, correct?
Yes, sir.
So the formula is coming half AC sine B, right? This
Yes,
is
sir.
the area of a triangle. Notice how the formula is structured. Two sides are there, C and A, and the angle between them, angle B, the included angle, that sign you have to take, right?
Yes, sir.
You could find the same area in a different way also, like this, dropping a perpendicular on the side B. This time the perpendicular length can either be written as C cos A or C sin A or A sin C, right?
Yes, sir.
Correct? No.
Yes, sir.
So C sin A half into C sin A into B into B. That is the area also, right? Or also half into A sin C into B, right?
Yes, sir.
So all of this gives us three different versions of area of the triangle. You can understand the pattern in the formula. Always you have to take two sides and the angle included between them, that sine, right?
Yes, sir.
So remember, this is an important result. So first you have what? Half base into height. And from there only we got that half BC sine A, half CA sine B, half AB sine C. This is also area of the triangle. And in this chapter and in chapter 15, we will be talking about area of a triangle with the symbol del. This delta, this triangle symbol or del will be the symbol that we will use for area of the triangle. In the book, he uses the symbol capital S. Okay.
Yes, sir.
In the book, he is using the symbol capital S. We will not be using capital S because it is easy to get confused between capital S and small s.
Yes, sir. Semi-perimeter.
So small s is semi-perimeter. We'll not say capital S is area. We'll always say delta. Okay.
Yes, sir.
So del is equal to this, all of this. And we also have the Heron's formula, which is root over s into s minus a, s minus b, s minus c, where 2s was equal to a plus b plus c, right?
Yes, sir.
You should try to prove Heron's formula. I mean, we can prove it, but you should try it yourself. Uh, it will be easier, I think, if you once we do sine rule and cosine rule. So if you can't do it right now, don't worry about it. But you should know that this is also a formula for area of a triangle, right?
Yes, sir.
So these are basic results for area of a triangle. The next thing that I want to discuss is sine rule. Sine rule. So first of all, if you have a triangle like this, ABC, this side is A, this side is B, this side is C, right? Now, in this triangle, it is very easy to prove a basic version of sine rule. Sine rule basically says A by sine A is equal to B by sine B is equal to C by sine C is equal to 2 capital R. And 2 capital R, here capital R means circumradius of triangle ABC. Do you understand the meaning of circumradius?
Yes, sir. The radius of circumcircle.
Right. So notice first the rule, the way the rule is make structured. It is like A by opposite angle, sine A, right? B
Yes,
by
sir.
sine B and C by sine C is equal to 2 capital R, right?
Yes, sir.
Now, it is very easy to show the basic fact that A by sine A is equal to B by sine B. You don't need much to prove that is equal to C by sine C. You just have to drop a perpendicular. If you see this
Yes.
perpendicular, the length of this perpendicular we saw was C sine B, right?
Yes, sir.
However, we could have done it on the other triangle also, right?
Yes, sir. B
In that
sin C.
case, so it is clear that B by sine B is C by sine C, right?
Yes, sir.
Similarly, it can also be shown with a different perpendicular. It is also A by sine.
Yes, sir.
You can take another perpendicular here and get the length in two different ways here, right?
Yes, sir.
But this proof is not perfect because it doesn't tell us the value of the entire three ratios. It just tells us that these three are equal. Doesn't tell us equal to 2R.
Yes, sir.
This is not the proof that we'll be using most of the time. I'm just showing it because I want you to realize that these are obvious things. The first three equalities.
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
Now what we will do is actually we want to prove that all the first three are equal to 2R. Right? That is what we really want to prove. Okay.
Okay, sir.
So what we will do here is think of circumcircle of this triangle. What is a circumcircle?
Like circle touching all the vertices.
We don't call it touching, we say it passes through, right?
Uh, yes, sir.
Touching would tell us about tangents and all.
Oh, yes, yes.
We will say it is passing through the three vertices. That circle is circumcircle. Do you know how to construct a circumcircle if you are given a triangle?
Uh,
You know how to construct the circumcircle.
mm,
In 7th grade, 8th grade, did you do any constructions in a triangle?
yes, sir, I did.
Circumcircle construction तो होता है ना?
Yes, sir.
Circumcircle, incircle constructions होते हैं lower classes में. कैसे करते थे circumcircle construction?
Um, like एक तो
Okay, we will see. So basically the idea is circumcircle you can only construct because first if you find circumcenter, right?
yes, sir.
First step is find circumcenter. Only then you can make a circle. So how do I find circumcenter? The way to find circumcenter is to draw perpendicular bisectors of
Oh,
each
yes,
side.
perpendicular. Yes, sir.
The meaning of perpendicular bisector is it should pass through the midpoint of the side and it should also be 90 degree to the side, right?
Yes, sir.
So if I have drawn a line like this passing through the midpoint perpendicular, so this is divided into two equal halves, right?
Yes, sir.
Notice that if I draw another line passing through the midpoint here, these lines will intersect at a point, right?
Yes, sir.
Basically, the two lines that I have drawn are perpendicular bisectors of BC and AC. Now,
Yes, sir.
a very important point here is that if I join this, or actually I'll do it on the next thing. This is my midpoint and I have drawn a line perpendicular to it. which is the perpendicular bisector of BC. Now what you should realize is any point on this line, point P, if I join PB and I join PC, you can prove that triangle PBC and triangle PDC are congruent. PBD and PDC. Do you realize that they are congruent?
PBD. Oh, yes, yes, sir.
Why are they congruent?
Like SAS.
SAS congruency, they are congruent. So therefore, we know that TB is equal to PC, right?
Yes, yes, sir.
So that means any point, P was a point that I chose randomly. There was nothing special about point P. P could have been here also, right?
Yes, sir.
Any point on the line which is perpendicular bisector is equidistant from the vertices, right?
Yes, sir.
If my point P was here, the distance PB is equal to PC, right?
Mm. Yes, sir.
So the perpendicular bisector line has this property that any point lying on it will be equidistant from the segment who you have done the perpendicular bisector.
Yes, sir.
Now, what is special about that? You have drawn two perpendicular bisectors. So point lying on both of them, if you see, this is the point of intersection, right?
Yes, sir.
It lies on both the perpendicular bisectors. So this point should be equidistant from B, from C, and from A, right?
Yes, sir. Yes, sir.
Why? Because since it was lying on this perpendicular bisector, distance of any point on it will be same as C to A, right?
Yes, sir.
And it is also same B to C, right?
Yes, sir.
So there is only one point which passes through both these lines, which is the intersection of these two perpendicular bisectors, such that it will become equidistant from A, B, and C,
No. Yes, sir.
right?
Yes, sir.
So that is how we find our circumcenter. That's my circumcenter, right?
Yes, sir.
If you are equidistant from the three vertices, then that point will be the point from where you can take this radius or this radius or this radius, right?
Yes, sir.
And then you can draw a circle easily, correct?
Yes, sir.
So the idea is that circumcenter is drawn by intersecting two perpendicular bisectors. Let's say this is my point O. I'm not drawing the other one so that the figure is clean. But the point is that OB is equal to OC is equal to OA, right?
Yes, sir.
And that distance is known as capital R.
Radius. Yes, sir.
Okay. Now look at this circle, and we know that the center of the circle is O, right?
Yes, sir.
So can you see that this angle A is an angle on the perimeter of the circle, and this angle is angle at the center by the same chord, right?
Yes, sir.
Chord is BC. The chord makes an angle A at the circle, and it makes an angle BOC on the center, right?
Oh, yes, sir. Like we will apply circle property.
So twice of angle A, right?
Yes, sir.
So now we know that angle BOC is twice of angle A, and we already showed that the two triangles here are congruent, BOD and DOC, right?
Yes, sir. Then
So
angle will.
obviously this angle will be half A and this will be A, right?
Yes, sir.
Now I have a situation like this, a small triangle like this, OBD, and the angle is A here, right? And this is 90 because it was perpendicular bisector, right?
Yes, sir.
And OB is called capital R, right?
Yes, sir.
And this base is called A by 2
Yes, sir.
because the whole side was A, right?
Yes, sir.
This base is a by 2. This angle is a, and now it's a right angle triangle. So I can easily say sine of capital A is equal to a by 2 divided by capital R, right?
Yes, sir.
So what am I getting? A by sine A is equal to 2 capital R.
Yes, sir. Then we can do all these things by mm, constructing perpendicular bisector from vertices B and C and A.
Now you don't have to do anything because you already know that A by sine A is equal to B by sine B is equal to C by sine C.
Oh, we will use the previous.
That proof was very easy, right?
Yes, sir.
We just needed to show one of them is equal to 2R, right?
Yes, sir.
Now we have gotten sine rule. A by sine A is equal to B by sine B is equal to C by sine C is equal to 2 capital R. This is true for any triangle, and this is super important. Okay.
Yes.
Similarly, you can also prove cosine rule, which is much easier to do. Like, let's say A, B, C you have. Let's drop a perpendicular AD. And notice that we can say that this angle is B and this side was C, right? This side.
Yes, sir.
So we can say AD is C sine B, and similarly we can say BD is C cos
C
B, right?
cos B.
And
Yes,
this
sir.
remaining part will be what? A minus C cos B.
Yes, sir.
And this is C sine B, right?
Yes, sir.
Correct? And this is 90 degree, and this one is B, right? This.
Yes, sir.
So we
Then
can
we
do
can apply
Pythagoras
Pythagoras.
theorem in this
Yes, sir.
triangle. ADC, we can say C sine B whole square plus A minus C cos B whole square is equal to B square. When you simplify, you will get A square plus C square minus 2AC cos B is equal to B square, right?
Yes, sir.
And you should remember it like this. You will solve for cos B. Cos B will come out to be A square plus C square minus B square by 2AC, right?
Yes, sir.
Once we have gotten cos B, in a similar way, you can say cos A will be B square plus C square minus A square by 2BC. And cos C will be A square plus B square minus C square by 2AB. You should realize that there is a nice pattern here.
Yes, sir.
You should be able to see a triangle and figure out how to write cos B. Notice that if B angle is here, then C is this one and A is this one, right?
Yes, sir.
You
They
are
both
doing
are
C,
containing that angle.
you are adding the squares there and subtracting the opposite square
Yes, sir.
and dividing by 2AC. Similar pattern is there everywhere, right? See,
Yes, sir.
so this is your sine rule and cosine rule, which is the first part of the next chapter, chapter 12. You should go through the first section and start the exercise of chapter 12. The first exercise of chapter 12 after going through the section theory. Okay. So
Okay, sir.
see, the work that you have to do is exercise 21. Read the theory before first exercise of chapter 12. I mean, there is no rush, but start working on these two things, right? We
Okay,
have,
sir.
in the next class, we'll finish the theory that is there in chapter 12. But you need to start working on it and then you have to start exercise for chapter 12, right?
Okay, sir.
If you do everything properly, we will be able to finish chapter 12 in 1 week or so. Then we can go to chapter 15.
Yes, sir.
So make sure that you follow the derivations. If you've forgotten the derivation, all of this in this chapter, it is very important to remember the derivations and know how the derivations are happening. If you don't remember the derivation and focus only on the formula, everything will go wrong.
Yes, sir.
Why will everything go wrong? You will realize in chapter 12 and chapter 15, there are 20, 25 formulas. There are many formulas, okay?
Yes, sir.
You can, students make the mistake that they just try to remember the formulas and try to solve the problems. But if you just remember formulas and try to solve the problems, what happens is when the question will come as an objective and you have 3 minutes to solve, you will not know which one to use.
Yes, sir.
If you don't know which formula to use, you will never be able to solve any question in time. And you will always keep getting confused. Yeah, should I use this one? Should I use that one?
Yes,
The,
sir.
the only way you will learn which one to use is if you know the actual derivations of each of the formulas. And when you know the derivations, automatically your brain will start thinking, okay, this is how you got this is how you got this question looks like this, then maybe I'll apply that method. You have to think about what you are doing and know all the derivations. Then only you can solve problems in this chapter. Okay?
Okay, sir.
So pay attention to what we have discussed. Go through the Esseloni theory carefully. See what he's saying, how he's getting.
Okay.
Okay.
Okay, sir.
We'll continue tomorrow then.
Thank you, sir.